So the first problem we'll be solving is number 32 of chapter 5 section 4, and it's solving this definite integral. The first step, what I did is I just made a random variable u equal to 2x because I know that this is in the form of arctangent, but I want it to be in the form of 1 over 1 plus x squared. And if you do 2x as an x squared, like this, we get 4x squared, so they're equivalent. So we're going to rewrite this as 1 over 2 u squared plus 1. So basically we just pulled the 2 out and used u to represent 2x du. Now we're going to pull out this 1/2 by the constant rule and do 1 over u squared plus 1 du. Now we have this in the form of arctangent, and we can do 1/2 inverse tangent of u because that's our x. So now 1/2 tan -1 2x. So I just replaced back our u. Now we're going to work with our limits of integration and do 1/2 tan to the -1 2x 0 to 1 root 3, and we get 1/2 tan -1 2 root 3 minus tan -1 0. So basically I just plugged each variable in, each limit in, and subtracted them, and this cancels out to 0, and we end with 1/2 tan -1 2 root 3. So our next question is from chapter 5, section 6, number 101. It's find the area of the region between the curve y equals 2x over 1 plus x squared and the x-axis in the interval -2 is less than or equal to x, which is less than or equal to 2. So first thing I did in this step was I graphed it out. So it basically looks like this after plugging some points in. So we're trying to find the area between this. Now, if you just take the area if you take the integral of this function and between -2 and 2, you just get 0 because these are going to negate each other. So instead, I split it up like this. The integral of -2 to 0, let's call this f of x dx, plus the integral of 0 to 2 f of x dx. So that way I can split it up and they don't have to negate each other. So the first thing I did was I did the integral from 0 to 2 of 2x over 1 plus x squared dx. Now, from here I did u substitution. U equals 1 plus x squared du equals 2x dx. So this is the integral from 0 to 2, u to the -1 du. I also changed my limits of integration to u of 0 equals 1, u of 2 equals 5, and I just plugged each x value into this u equation. This gives us ln, absolute value of u, from 5 to 1, and ln 5 minus ln 1. Okay, this is just for part of it. Now if we do the same thing for negative 2 to 0, 2x over 1 plus x squared dx, u equals 1 plus x squared, du equals 2x dx, and u of 0 equals 1 still, and 0, u of negative 2 equals 5 still. And we get 0, negative 2, u negative 1 du, and again end with ln u from 5 to 1, and ln 5 minus ln 1. So now we are going to add our two things. So the answers from both of these integrals, ln 5 minus ln 1 plus ln 5 minus ln 1. So first of all, ln 1 is 0, so those cancel out. ln 5 plus ln 5, we get 2 ln 5, and that's the area under the curve from this interval, and it's the area between this function and the x-axis.